The universe, though vast and seemingly chaotic, is built on an intricate structure, a cosmic web that spans billions of light years, shaping galaxies, stars, and ultimately, life itself. But how did this structure form from the aftermath of the Big Bang? It all began with tiny fluctuations, microscopic variations in density. So small they were mere 1 in 100,000 differences in the early universe. These fluctuations are preserved in the cosmic microwave background, CMB, a faint afterglow of the Big Bang that fills the entire sky. Like fingerprints frozen in time, they offer a snapshot of the baby universe. These quantum fluctuations, stretched to cosmic scales by inflation, acted as seeds for everything we see today. Gravity took hold of these denser regions, drawing in more matter and amplifying their growth. Over billions of years, these slight overdensities became galaxies, clusters, and the immense filaments of the cosmic web. The cosmic web is not a metaphor. It's a literal structure. Simulations and deep space surveys reveal a network of interconnected filaments made of dark matter and gas, with galaxies forming along these strands like dewdrops on a spider's thread. These filaments intersect at nodes called galaxy clusters, the densest, most massive structures in the known universe. In between these filaments lie vast cosmic voids, immense, empty regions with almost no matter. These voids are just as important as the filaments. They help define the geometry of the web. Think of it like a sponge, full of holes and tunnels, only on a scale of hundreds of millions of light years. Dark matter plays a crucial role in shaping this structure. Although invisible, it makes up about 85% of the total matter in the universe. It interacts gravitationally, guiding the formation of galaxies and binding them together. Without dark matter, the structures we see wouldn't exist. But dark matter alone isn't enough. Baryonic matter, the kind we're made of, follows the blueprint laid out by dark matter. After recombination, when the universe cooled enough for neutral atoms to form, baryonic gas began to collapse into the gravitational cells created by dark matter. Over time, these regions became hot, dense, and luminous, birthing stars, galaxies, and planets. Star formation ignited feedback loops. Exploding supernovae enriched the interstellar medium with heavier elements, while black holes at the centers of galaxies stirred and shaped their hosts. These processes turned the raw ingredients of the cosmos into complex systems. But it didn't happen all at once. Structure formation is a hierarchical process. Small galaxies formed first and merged into larger ones. Galaxy clusters formed later, accumulating mass over billions of years. Even today, galaxies are still colliding, still growing, still evolving. Telescopes like the Sloan Digital Sky Survey and the Dark Energy Survey have mapped millions of galaxies, revealing the skeleton of the universe. Their data confirms what simulations like the Millennium Run predicted: a fractal-like distribution of matter on the largest scales, governed by physics, randomness, and the initial conditions of the cosmos. Interestingly, this large-scale structure tells us more than just where things are. It also holds clues about what the universe is made of and how it's evolving. By studying the distribution of galaxies, cosmologists can measure the effects of dark energy, the mysterious force accelerating the expansion of the universe. Ripples in the matter distribution, known as baryon acoustic oscillations, serve as cosmic rulers, allowing us to trace the history of expansion. These sound waves from the early universe left imprints in the density of galaxies, and they act like a yardstick across space and time. And here's a profound thought. The very atoms in your body were once part of those ancient waves. The calcium in your bones, the iron in your blood, all originated from stars that formed along these filaments, which themselves formed from fluctuations in the primordial soup. You are, quite literally, a child of the cosmic web. This perspective transforms our sense of identity. We are not isolated observers. We are products of cosmic processes that began nearly 14 billion years ago. Our bodies, our planet, even our thoughts, all shaped by the hidden architecture of the universe. And we are still learning. Upcoming telescopes like the Euclid mission and the Vera C. Rubin Observatory will map the universe in unprecedented detail. They'll peer deeper into space and further back in time, allowing us to refine our understanding of structure formation. New computer simulations, powered by artificial intelligence, will model the evolution of cosmic structures across billions of years with astonishing precision. Some theorists even propose that the cosmic web might influence consciousness, that the large-scale connectivity of the universe echoes the structure of neural networks. Though speculative, such ideas point to a growing recognition of the deep, perhaps poetic resonance between cosmos and consciousness. At Infinity Beyond, we explore these vast themes not just for science, but for meaning. The universe is not just a place, it's a story, and we're part of its unfolding narrative. In our next segment, we'll leave the large-scale structure behind and dive into one of the most mysterious forces shaping that structure: dark energy. What is it, and why is it pulling the cosmos apart? Subscribe and stay with us on this remarkable journey across time, space, and structure.